Hello, we are from Group 2. We'll present to you a video about single-phase induction motor. Meet our team.
First of all, we're gonna define the definition of the single-phase induction motor. Single-phase induction motor is a type of electric motor which works on the principle of induction. The motor is supplied through single-phase AC supply. When supplying a single-phase voltage to the stator of this machine, this stator will produce flux. This flux then rotates and cuts the rotor conductors. Due to this, an EMF is induced. For your information, single-phase induction motor is a popular type of AC electrical motor which used widely in many areas. You can find its application in domestic, commercial as well as industrial purpose such as fan, refrigerators, washing machine, vacuum cleaner, kitchen equipment, farming appliance and many more.
Construction of single-phase induction motor consists of stator, rotor and frame. Stator is made up of a few stampings. It is the stationary part of the motor. It has slots to accommodate winding. Rotor consists of a cylindrical laminated core. It is the moving part of the motor. It has a number of parallel slots with a conductor bar in each slot. All these bars are joined at each end by metal rings. Rotor contains bearing for smooth rotation at end belts and it has a shaft attached to it. Frame is used to cover stator and rotor with end cover. It has ventilation fan and terminal box.
Moving on to the operating principle. When a single-phase AC current is supplied to the stator winding, magnetic field will be produced. The produced magnetic field is fluctuating. The rotor will keep on rotating in the same direction as the fluctuating field is the sum of two oppositely rotating magnetic fields. When the two rotating magnetic fields are opposite, an equal and opposite torque will be produced. The total torque will then be zero, and the rotor won't start. Therefore, a single-phase induction motor is not self-starting. This can further be explained by using the double revolving field theory. The basic idea behind this is that any alternating quantity can be resolved into two equal components rotating in opposite direction. Alternating flux produced by the stator is represented by Phi1 and Phi2. Each of the fluxes is equal to half the maximum value of alternating flux, and they rotate at synchronous speed in opposite directions. Flux Phi1 will result in the torque T1 in the anti-clockwise direction, and flux Phi2 will produce a torque T2 in the clockwise direction. When the rotor is in rest condition, torques T1 and T2 are equal and opposite and the net torque developed will be zero. Therefore, the single-phase induction motor is not self-starting.
Types of single-phase induction motor. Split-phase induction motor, also known as a resistance start motor. It has single cage rotor and its stator has two windings known as main winding and auxiliary winding. The main winding has a very low resistance and high inductive reactance, while the auxiliary winding has high resistance and low inductive reactance. Both are displaced by 90 degrees in space. Moving on to capacitor start induction motor. It is a single-phase induction motor that employs a capacitor in auxiliary winding circuit to produce greater phase difference between the current in main winding and auxiliary winding. IM is the current in main winding, which is lagging the IA by 90 degrees. Thus, a single-phase supply current is split into two phases. Next is capacitor run induction motor. A capacitor run motor uses a capacitor permanently connected in series with auxiliary winding, creating and maintaining a phase difference between the two windings of motor. The fields by these two windings create two magnetic fields, which effectively produce a rotating magnetic field acting on the rotor. Torque produced by this field keeps the rotor spinning.
Capacitor start, capacitor run is identical to capacitor start induction motor except that the starting winding is connected when the motor is running. It uses two capacitors, capacitor 1, a low value capacitor for optimum running, capacitor 2, a larger value capacitor for optimum starting. At the time of starting, both capacitors C1 and C2 are connected, having equivalent capacitance C1 plus C2. IS will lead V by a larger angle, and the angle between IM and IS is larger. Starting torque is more. When the synchronous speed reaches 75%, centrifugal switch will disconnect C2, leaving only C1 to be connected. Angle of IS from V and angle between V and I is now decreased. Motor will now keeps running in this configuration. Shaded pole induction motor is a self-starting single phase where one of the pole is shaded by the copper ring. The copper ring is also known as shaded ring, which acts as a secondary winding for the motor. When supply is connected, the alternating flux induces. The flux induces in the shaded portion A and unshaded portion B, having a phase difference. The main motor flux and the shaded ring flux has a space as there is time and space displacement between two fluxes. The rotating magnetic field induces in the coil and develops starting torque. The field rotates from the unshaded portion to the shaded portion of the motor.
That's all from us. Thank you for watching.